Welcome to Q&A. This is week 5, and it's part 2. So we're going to do 2 Q&As for week 5. In this Q&A, I would like to go over your multiple choice questions from your quiz 5. Because you're going to need to learn how to think through those problems and solve those problems for exam 3. Exam 3 is going to cover pretty much chapters 7, 8, and 9. And chapter 7 really talks about alkenes and the stability of alkenes and the properties of alkenes, and then elimination reactions, and you have an E1 and an E2. And then chapter 8 will be electrophilic addition reactions for 2 alkenes. And then chapter 9 is electrophilic additions to alkynes. And so those are all lumped together for exam 3. Your last POGIL activities this week are POGIL activities week 6. And students are doing pretty good on those. So I'm encouraging you to draw your intermediates and show your electron flows for some of these. And the only reason why is because the POGIL exercises, 25 out of 25, is I just take a half a point just to bring to your attention when you do something incorrectly, because it can be worth up to 5 points on your exam. And I want to be able to give you feedback. But if you just write your answers and you don't draw the different feedback and the intermediates, then it limits how much information I can give back to you and correct your thinking. And then you don't get that feedback until exam 3, and that really impacts your grade. I really would like to see you get the highest grade that you can possibly get. Okay, so just a heads up on that. And like I said, a couple of people have already turned in week 6 POGIL, so they're going to do really well on their last quiz, quiz 6, on I want to say Monday. Let's look and see course information. I'm going to the learning modules, and I'm going to see week 6. Yes, Monday you have quiz 6. So that is going to be pretty much over chapter 8. So it's going to be over these POGIL activities that you're seeing on week 6. So if you can get your POGIL work turned into me this weekend, then you're going to do better on your Monday quiz. And that is due at the end of the day on Monday. The other thing, one thing we're going to go over here is I'm going to go over your week 5 POGILs. Okay, so everybody's pretty much turned that in except for maybe 1 or 2 people. And I'd like to give you feedback on what I'm looking for so you can once again get those points on exam 3. All right, so let's start on our multiple choice questions, quiz 5. Going back to the beginning. Like I said, just a reminder that you have POGIL week 6. Try to get your intermediates in there. I'm also going to give you what do you call that, the exam wrapper. Some people wanted that, so I will send that out and put that on our last learning module for week 6. I'll put that file there just like I did before. And if you turn that in with a self-reflective exercise filled out, you can get 5 points bonus on your exam 3. So that always kind of helps as an answer. Okay, and then I wanted to give you week 5 POGIL feedback. Okay, so your question here is about cis and trans alkene, which is a E-alkene. Well, what's an E-alkene? E is trans. And so we see this molecule here, and this has a hydrogen and a hydrogen. Okay, so these are the same. So we have no E or Z, no cis or trans, and these are the same. Anytime you have the same um, groups coming off of your carbon double bond, then you have no cis or trans. It's called no cis trans isomerism. Okay, another option was this compound here. Once again, you see that on this first carbon here of the carbon-carbon double bond, you have a fluorine of fluorine. These are the same. So there's no E or Z. Here we have this molecule here. Now you have, so this first carbon, you have a hydrogen that's not put there, and you have a carbon. So which one has a higher atomic number? The carbon. So this gets a 1, and this gets a 2. Then you go to the next carbon, and you have a carbon versus a carbon. Well, those are the same. So then this one's connected to another carbon, another carbon. So this would have a higher atomic number. It's the same thing, same concept as what you did when we were doing. All right, so when you have the higher priorities, just like when you're assigning R and S, this would be a number 1, and then this carbon would be number 2. And so if you circle both your 1s, and if they're on the same side, that's a cis, and a cis is also Z. Okay, well, this problem asks for E alkene. So you look at the other compound, you have a choice. And like I said before, I would work each one of these as an open response. Okay, so the first carbon, what two things you have? You have a carbon or a fluorine. So the fluorine is going to be a number 1 because it has a higher atomic number than carbon. And then you go over here and you have a fluorine or a bromine. And bromine, get a periodic table. The atomic number for bromine is 35 and fluorine is 9. So bromine is number 1, and then fluorine would be number 2. And then you see you have 1 over here and 1 over here. And since they're across the double bond, that would be opposite sides. That's trans, and that would be E. So this would be the correct answer. All right, so one of the questions that you had on quiz 5 was to rank the thermodynamic stability of the different alkenes. And these were your your alkene examples. So I will draw these out for you, and then we will problem solve. All right, so it says list the most thermodynamically stable compound first. All right. Well, let me just tell you, this is the least stable. This is so unstable that it is considered not stable. And if you look in your textbook on the alkenes and the stability in chapter 7, it talks about the bicyclo compounds. And so see, this is about the bridgehead. So this is a bridgehead carbon, and this is on page 352 in chapter 7. And it shows that the bridgehead carbons are unstable because it's a Brett rule violation. And so this is a trans. This is a trans. You have to have at least an 8-membered ring. And this is a 6-membered. So 1, 2, 3, 4, 5, 6. So it's a violation of Brett's rule, and these are not stable at room temperature. Okay, so this is the least stable. And if you look at that, there's only one that has one as the least stable. Okay, and so that was one option, with this being the least stable. And then the other ones you have to choose from. So 4 is the most stable. And the way you look at this is di-substituted, and it's also a trans. So this is the most stable. And then 2 here, between 2 and 3, this is supported by benzylic ring, and it's a mono substituted. And this is also mono, but it does not have the aromatic ring. So that would be your choice. Okay. What? Here we need to predict the product. And so you're getting into these kinds of reactions where you have to sometimes figure out the starting material. Other times you need your reagents or your products. And there's where reaction sheets will be helpful for you. Okay, so what is this compound here? Whenever you see potassium and magnesium, just go ahead and make that a negative. I mean, oxygen a negative with a carbon a positive. And then you have this here. And this is called potassium tert butoxide. And when you look at your reactions, this is a strong base. Anytime you have a strong base, a negative oxygen, a negative charge, you're going to have E2 conditions, okay? You will not have a negative charge under an E1 condition. So when I look in your book on the E2, I'm coming to a page 364, and these are bulky bases. And bulky bases are called Hoffman bases. And Hoffman gives you a Hoffman product. A Hoffman product is the opposite of a Zatsev's product. So do you remember what a Zatsev's product was? Zatsev is the most substituted alkene. Okay, so a Hoffman is going to be the least substituted alkene. Now you see how I think about all this stuff and the reagents before I ever look at the problems. Okay, so that's how you solve these. Okay, so then I look at this. I haven't even looked at our options. I see this. I want to label my beta hydrogens. Okay, so you all have been doing that pretty good. So here's my alpha. My alpha carbon is the one linked with the leaving group. And so my beta hydrogens are here. So these are beta, and then I have a beta hydrogen here. Okay, so I have 2 betas because this is a secondary alkyl halide. So a secondary alkyl halide is going to have 2 betas. Now, if I chose this hydrogen here, that would give me a Zatsev's product. But if I choose from the more hydrogens, I'm going to get the least substituted. And be sure to be able to show your reaction mechanism. So this will be a Hoffman. So on your reaction, your open response, you have to show mechanisms. And you notice I have 3 electron flow arrows because you're telling the story here. Okay, so that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I count my carbons, and then I count them again. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that is my product. Now I look and see 1, 2, 3, 4, 5, 6, 7, and I see the product. Okay. The other options that I see here is this option here, and that would be a Zatsev's product. Okay, so that's the more substituted. Maybe some people chose that. Some people might have decided that's not an E2 but an SN2. These bulky bases are non-nucleophilic. Okay, so they're never going to add and do substitution. So these bulky bases, you're never going to get an SN2 reaction. Okay, this is going to be only E2. And these are Hoffman, so you're going to get the least substituted. And the other compound option here is the wrong beta hydrogen. Okay, we have another predict the product. All right, so now we have the exact same starting material, but we have a different base. This one is a sodium methoxide base. So here we do the plus and the minus, and we put in our beta hydrogens. And then this time we're going to get a Zatsev's product because it's not one of the Hoffman bulky bases. It's going to come here. Those electrons are going to go here, and you're going to do an E2, and then you redraw your product here. Okay, so there you have the Zatsev's product, and you had very similar choices. So what was wrong with this choice here was this is a Hoffman. So that was not a good choice. This one here, you would have gotten this if you had E1 conditions, okay? But these are E2 conditions. And then this one here, I don't know how you would get something like that because that's not even an SN2 because you got an alkene. So this is kind of like a mixture. Not going to get that. All right, we have one more. It's called elimination product. So which is the major organic product for this reaction? And let's see what we have here. Okay, this is sodium ethoxide and heat. So we want to see an E2 here. We see that that's a strong base. Okay, so you're going to be elimination. Now for these, you need to draw these in the chair conformation. So draw the chair. Put your leaving group in the axial position, and then locate a beta hydrogen that's 180 degrees anti-paraplanar to the leaving group. And that's going to determine what product gets made. So you draw your chair, and you say, okay, we're going to make this your carbon here with the leaving group, and put the chlorine in the axial up. And then if I go to this carbon here, that is going to be a CH3 down. So this is up, this is down, and this is down. So we come to here, and this hydrogen has to go axial up. So this would be equatorial down. And then you can put in your beta hydrogens. So this is your alpha. So here's a beta hydrogen. And then this carbon here has the beta hydrogens. Now, you only have one choice. This base can only get this hydrogen. I'll highlight that hydrogen. Can only get that hydrogen because that hydrogen is in the axial position that is 180 degrees from the leaving group. So those electrons go there, and then those electrons go there. You can draw your chair like this, but then you need to be able to convert it to the two-dimensional drawing. So that would be with the dashes and wedges. So if we make this our carbon-carbon double bond, then this carbon here would be CH3 down, this carbon would be down. And you can see that from your starting material, you didn't touch these other stereo centers, so you just leave them the same. And you do have that choice. If you chose this choice here, which was wrong. Okay, the problem is you can't you can't abstract this hydrogen. You cannot take it's not in the right orientation of 180. The other option you had was the more substituted, but you don't even have a leaving group. You'd have to have something E1, and then the less substituted, like a Hoffman. Once again, this is an E2, and so that's why these do not work. Okay, so that goes over your multiple choice for quiz 5. The other thing we wanted to do, so for week 5 POGIL, your exercises were the elimination reactions. So we had 10A and 10B. Okay, and these POGILs were actually probably not as good grades as what we've seen throughout. And I think it's because I'm expecting all the structures to be drawn, okay? I expect all structures to be drawn. I expect electron flow arrows to be drawn. I mean, I have to give you feedback on this. And so I'm grading this as if I would grade it for your exam, for your open response. And I don't want you to go in exam 3 and lose 50 points because you didn't understand that you need to label beta hydrogens and draw electron flow arrows. Okay, so let's go over 10A. You have this compound here, acetone, and you have a strong nucleophile. Now, this is going to be E2 because you have a primary alkyl halide, and these were all considered to draw possible elimination because obviously you would have competition. So there's your alpha, and so this is your beta, and I want you to draw the beta hydrogens in, and then you come here and you show your electron flow arrows, which are 3 of them, and then you got 1, 2, 3, 4. So there is your product. Most people got the product, so fine, but not everybody drew in their beta hydrogens and showed me the electron flow arrows. Now I'm just letting you all know I will be asking for the major. So I know POGIL asked for all, but I'm just wanting to know the major. There's your alpha, here's your beta, and this time you have sodium methoxide. So be sure to show your electron flow movement where the sodium methoxide takes the beta hydrogen, those electrons form the double bond, and chlorine leaves with those electrons. So your elimination product is this, and then chlorine takes those bonds. So your electron flow arrows are telling the story. Okay, you get down to this problem here, and now you have a choice because you have regiochemistry. So here's your alpha, so here's your beta. So on the test, you use sodium hydroxide. I want to just see you go for the more substituted hydrogen to give you the Zaitsev alkene, which is the more substituted alkene. Now, let's go to D. All right, now sodium methoxide, folks. This is a strong base. Strong base, it's a strong nucleophile. Yes, this is a tertiary alkyl halide. Tertiary alkyl halides in a strong base will go E2 fast. Okay, so tertiary is a little different when it comes to elimination. So you have your alpha here, and then you have your beta hydrogens. So this sodium methoxide will take this hydrogen, and that will leave. And you end up having a product like this. Do you have cis or trans for this one? No, because CH3 and CH3 are the same thing. Now, the other thing, could this be an E1? Some people thought E1. No. Okay, you're not going to have E1 conditions with a strong base. No, if you have a negative charge, please do not go E1. Okay, E1 forms a carbocation, and if you form a carbocation, you're going to have a polar protic solvent. You're going to have hydrogens stabilizing that. You have to generate an acid environment, okay? So you're not going to, you can't have one, you can't have both E1 and E2 conditions. It's one or the other. E1 is going to be more acidic, and E2 is going to be the negative oxygen basic. All right, which brings us to the last problem for number 17, which is a pesticide. And it asks elimination in HCl. Do you see that? Well, okay. So, but it actually asks for base 2. So, let's see. So this is what I was hoping for. So you could just notice that in HCl, you are going to get an E1. And so that means you have a leaving group. Put in my beta hydrogen here. And whenever you have an E1, I want to see the carbocation. And then this would just go there. And most people got the product correct. So, good job. But I want you to be able to see the difference between an E1 and an E2. And it's basically, this is HCl, so you want E1. Basic conditions, you want E2. Now, the next POGL, 10B, is really about the stereochemistry of an E2 elimination. So with E1, you always got to form your most stable carbocation. I do agree, most people were like, hey, 7C is the same as 7A. Okay, so let's just do 7A. Now, when it talks about rotation, and I just wanted you to draw a Newman projection. Once again, POGL is just for me to make sure that you understand how to do things. So can you draw a Newman projection where you see that this front carbon, so if you put what's in the plane here, okay, so this is your plane, the red. Okay, that's your plane. And then what's on the dash here, or the wedges, CH3, and you can write CH3 in there. And then what's on the dash is going away, put it on the green. Then if you go to your back carbon, okay, then, well, you want what's on the plane here, so you want the CH3 here. There's your CH3. The bromine should be on the same side as what's on your wedge here. So this would be bromine. And then what you don't see here is the hydrogen in back. So the hydrogen's in back. So you see that these are on the same side. This is your dash, and this is your wedge. Now, when you come in with a base, and the base takes this hydrogen, okay, and the bromine leaves. Okay, so this is your plane. This is your 180 degrees anti-paraplanar. So your base comes in, and it's going to take this hydrogen. Those electrons are going to form a double bond, and the bromine's going to leave. And what some people have done is then do this CH3, CH3. So you have this here and this. And then you can have this here, isopropyl, and then it goes back to this hydrogen. And the reason why this is important is because it shows you whether you have a cis or a trans. Okay, so what do you have? Well, look at the first carbon. You got it. Number one priority is isopropyl. Go to here. What's the number one priority? The methyl. They're on opposite sides. So this is a trans alkene. So one of the things you need to be able to do is just show the stereochemistry involved. Now for 7b, you have chair. Okay, so they give you this problem here, and it's not in the right conformation. Okay, so what you have to do when you have these cyclohexanes is you're going to have to do a flip. Okay, so even though it's just here a little bit, you see my equilibrium arrow. So if this is that carbon here, this is up, equatorial up, it's going to go axial up. Okay, so you got to do the flip, and then you have 1, 2, you got the bromine here. The bromine's equatorial up. If you can't see this, put the hydrogen down. Put the hydrogen down there. Put the hydrogen up here. This hydrogen's up. Remember, they're alternating in the chair. So this is going to be bromine axial up. And then what we care about then is the beta hydrogen here. And you can see that now we can have our base. They could come in and take that hydrogen, and it's in the right 180-degree antiparaplanar for the E2. And then that reaction would look like this. And then this would go like that. And then you would want to be able to convert that to a two-dimensional. Okay, 1, 2, 3, 1, 2, 3. And so that would be your two-dimensional. Sometimes you'll have to choose it two-dimensional in a multiple choice question. Sometimes you'll just have to do it open response. Okay, now let's do D. So 7D. So here's your problem. You have bromine up, you have methyl up, and you have a tert-butyl down. Okay, so just pick one. Let's pick this one, bromine up, and then we have this one, and that would be a hydrogen down. So it's methyl up. This one's hydrogen up, so it would be tert-butyl down. And we also have a hydrogen down. Now I'm going to ask for major, so I'm just going to show you the major. The major is going to give you this hydrogen here. Those electrons are going to go here, and then bromine's going to leave. And I just go straight into drawing the right conformation with the bromine up, so that way I don't have to draw a bunch of examples. Now this CH3 is going to lose its stereochemistry on a sp2 carbon. So when I convert this to a two-dimensional, I've got to make sure I have the right 1, 2, 1, 2. There's my CH3. Notice I don't have any wedges or dashes on an sp2 carbon. And then we go here, and then you see how it's going down. We're going to keep it going down. All right, and there's your product for 7D. So people lost a point if you didn't draw your chair conformations properly or Newman projection. Okay, and then we have the last one for this. Actually, no, we have, everybody did fine with the electrophilic addition 11A, so I'm not going to go over that, but let me just go over a couple on 8. Okay, so some of your problems on 8. And these look kind of familiar. We've already looked at these, actually. You have to decide whether you're going to have SN1, SN2, E1, or E2. And so the first one, everybody got the first one right. But make sure you show your electron flow arrows. So this would be SN2, and the reason why, you have a strong nucleophile and you have a primary alkyl halide. So you are definitely going to have an SN2. It's going to happen fast. So really, what's going to happen the fastest? Because whichever happens the fastest uses up all your starting material. So sodium methoxide here, I would choose an SN2. This is a pretty much unhindered secondary alkyl halide. You have a strong nucleophile, strong base. So when you draw your 2 electron flow arrows, and then we don't have to show stereochemistry because it's not shown in the starting material. Here, now we have sodium cyanide. Now, sodium cyanide will not be basic, so you're not even going to have to worry about an E2. So this is going to be an SN2. Okay, so that's cyanide. And also you have an apolar protic solvent in all of those. Okay, so for D people missed. And once again, we've gone over it, why people missed it. And the fact is, you're not going to have any kind of E1. Okay, I think that's what people missed. So this is sodium. This is a tertiary alkyl halide. This is a strong base. Okay, so tertiary alkyl halide can do an E2 fast. Very fast. This would be very, very fast. Okay. And then the last one, I wanted you to show your mechanism. Like I said, the more times you can draw mechanisms on here with electron flow arrows on your POGIL, then I can help you out so you don't lose points on your exam. Okay, this is a weak nucleophile. Whenever you see a weak nucleophile, you can start thinking, either E1 or SN1. And you don't have any heat or anything, so I'd like to see the step mechanism. Some people decided to draw like it's an SN2. It's not. You have to do step 1, leaving group leaves. Make sure that's your carbocation, the most stable carbocations. Do your test. Then you have water adds, and then you want to deprotonate that, do a proton transfer to make sure that your product that you report is neutral. And so most people got the SN1, but you lost a half a point if you drew it, or a whole point if you drew it like an SN2 mechanism. Okay, we also did 11A, and this is the introduction of electrophilic addition. So on your electrophilic addition, people have asked what reactions to note, and basically you want all the reactions that we cover in 11A, 11B, and 11C, and then also in 12. At the end of your chapters, you do have some great summaries. So if you do ask me for reactions, I say for your reaction sheets, you should have, so for your reaction sheets, you should have an acid-base reaction. Okay, so you can have some acid-base reaction examples. You should have SN1 examples, SN2 examples, E1, E2 examples. And then you're getting into chapter 8. Oh, you should also have, from chapter 4, you should have a radical chain reaction example. So you take an alkane and you make an alkyl halide on it. And then the reaction summaries at the end of your book, I I see you have some on page 451 in your textbook. You also have page 452 in your textbook. So those are some reactions of alkenes. And then the last page of reaction of alkynes is, let me see what page number that is. Page 491. 491 for alkynes. So you can look at those summaries, and those should be helpful. All right, good luck, and I also will put a Q&A next week on a Tuesday or Wednesday, and I will post an exam wrapper. Work hard. This is your last week, Organic 1.